In Lesson 4, we're going to look at comparing and ordering integers and other rational numbers. So if you look at example 1, it's giving us a bunch of points that they want us to graph on the number line above. Looking at this number line, we can see it's counting by twos. So 0, 2, 4, 6, 8, 0, -2, -4, -6, -8. If we look at the points that they're given to us, these points aren't directly on our number line. So the first thing we have to do is determine where on the number line it would fall, then label and graph it. So -7, if it were +7, it would fall between 6 and 8. Since it's -7, it's going to fall between -6 and -8. It's directly between the two, so directly between -6 and -8. I'll put a line, label that as -7, and put a point there. +5, hopefully we all know, falls between 4 and 6 on this number line. So again, put a line directly between, put the number 5, and put our point. Letter C is a little different. It includes a decimal. So this is -2.5 or -2 and 5/10. Now if this were positive, 2 and 5/10 would fall on our number line between 2 and 4. Since it's negative, it's going to fall between -2 and -4. So what I would do here is I would do halfway, which is -3. That would fall directly between -2 and -4. And then I know that 2.5 is halfway between 2 and 3. So that means -2.5 is halfway between -2 and -3. So halfway between -2 and -3, I would put another line. I would put my point, and I would write it in as -2.5. The next one, -4 and 3/4. If it were +4 and 3/4, it would fall between +4 and +6 on the number line. Since it's -4 and 3/4, it would fall between -4 and -6 on our number line. Once again, just like I did with our decimal here, I'm going to split this in half to see that -5 would fall here. -4 and 3/4 would fall between -4 and -5, just as +4 and 3/4 would fall between 4 and +5. What I'm going to do next to pinpoint where this would be exactly is I'm going to use the idea that my denominator is 4 here. So I'm going to split in between -4 and -5 into 4 equal sections with 3 lines. Directly to the left of -4 would be -4 and 1/4, then -4 and 2/4, and then -4 and 3/4. It would be closer to the -5 than to the -4. Okay, so now what we're going to do is look at inequalities. Inequalities just are referring to symbols like these: less than, greater than, or equal. Later we'll introduce some more inequality symbols as well, but right now we're going to stick with less than, greater than, or equal. So it wants us to compare the following numbers, and with these we always read left to right. We can use the number line here to help us because anything to the left is less and anything to the right is greater. So as we move left, the numbers get less. As we move right, the numbers get greater. So if we're going to compare, the first one we're looking at is to see if if -7 is less than 5, -7 is greater than 5, or if -7 is equal to 5. Hopefully we all know it's not equal. Looking at these two numbers, I can see that one is negative and one is positive. A negative number is always going to be less than a positive. A positive number is always going to be greater than a negative number. So in this case, I would say -7 is less than +5. I know some kids have a hard time with which one is less than, which one is greater than. When you're looking at this, a lot of people think of it as that alligator mouth. So here's my alligator, and it wants to eat the number that's more. So the chompers are heading towards that greater number. It's still a less than symbol because the less or smaller number is first. With the number line, if you look at it, here is -7, here is +5. -7 is further left to on the number line than 5, which means it's less. Looking at the next one, it's not as easy as the first one because it's not a negative and a positive. It's two negative numbers. So again, you can use your number line to determine if -7 is less than, greater than, or equal to -2.5 by looking at if it's to the left or right of the number. So -7 is here, -2.5 is here. So -7 is to the left, which means it's less than -2.5. One way that I actually do this for myself is I turn both numbers positive. These are the opposites of this number. The opposite of -7 is +7. The opposite of -2.5 is +2.5. So on the positive side, I would be looking at the whole numbers, 7 and 2. I know 7 is greater than 2. But since we're talking about the opposites of these numbers, it would be the opposite symbol. So instead of saying 7 is greater than 2.5, I'm going to say -7 is less than -2.5. So that's just the way I do it. I find it's really helpful. Letter C is looking at +5 and -2.5. A positive is always greater than a negative, so I'd use the greater than symbol. Looking on the number line, +5 is to the right of -2.5, so it's greater. Letter D, I'm looking at -2.5 and -4 3/4. They are both negative, so I can use my number line to help me. -2.5 is to the right of -4 3/4, which means -2.5 is the greater number. So -2.5 is greater than -4 3/4. If I'm using my opposites method, the opposite of -2.5 is +2.5. The opposite of -4 3/4 is +4 3/4. Looking at the whole numbers, 2 and 4, 2 is less than 4. So if I'm looking at the opposites, it would be the opposite direction. Okay, so example 2 wants us to graph and label the following points on the number line. So if we look at all of these points, we notice that we've got fractions, decimals that we need to graph. So there are a couple of different ways we can do this. We can either turn all of the numbers into decimals or turn them all into fractions. I'm going to do all of them into fractions right now just because I think it's easier to do the denominators, but it really doesn't matter which way you do it. You can turn them all into decimals. First thing we should actually notice is that they all start with -1. So they all have a whole number of -1. What that means on the number line is it's all of these numbers are going to fall between -1 and -2. Now, I would look at my decimals and say, okay, this is -1 and 6/10, which as a fraction is -1 and 6/10. This is -1 and 8/10, so -1 and 8/10. Now, if we look at them all as fractions, we can also see that they all have different denominators. In order to put them on the same number line, we need them to all have the same denominator. So if I look at 5, 10, 2, and 10, they can all go into 10, which means I can turn them all into tenths. So I would just pull over my -1. 5 goes into 10 2 times. So this becomes -1 and 2/10. Pull over my whole number. 2 goes into 10 5 times. 1 times 5 is 5. So this becomes -1 and 5/10. So since all of them have a denominator of 10, I am going to split in between -1 and -2 into 10 sections. So remember, split it in half, 4 on either side. Since it's starting with negative 1 would be in front of all of our numbers in between here. Since we split it into 10 equal parts, the first one next to negative 1 is going to be negative 1 and 1/10. Negative 1 and 2/10, negative 1 and 3/10, and so on, all the way up to that negative 2. Okay, so now we can go ahead and put them on the number line. So negative 1 and 2/10 is point A. Negative 1 and 6/10 is point B. Negative 1 and 5/10 is point C. And negative 1 and 8/10 is point D. It says using the number line, put the numbers in order from least to greatest. On a number line, least to greatest is just simply left to right. So I would start with point D, which was negative 1 and 8/10. If I go back to the original problem, it was written as a decimal, so I'm going to write it as a decimal. As long as I show that these two are equivalent somewhere on my paper, I could also write that mixed number, but again, I would have to show it's equivalent. Moving over to the right, we have point B, which is negative 1.6. Again, I could write the negative 1 and 6/10 as a fraction if I had that showing that they're the same. And then we have C, which was the negative 1 and 5/10, which was originally negative 1 and 1/2. And then point A, which is negative 1 and 1/5. Okay, so the next piece is talking about inequality statements. Again, inequalities are just talking about less than, greater than, equal, and some other symbols we'll be learning later in the year. It says the amount of money I have in my pocket is less than $5 but greater than $4. One possible value for the amount of money in my pocket is, and most kids just tend to pick $4.50. They know it's directly in the middle, so they choose that. If I want to graph all three of these numbers, meaning $4, $5, and the $4.50 on a number line, I would start my number line with $4 and end it with 5. We can see that our number line is split into 4 equal sections. So if I take the dollar that exists between $4 and $5 and split it into 4 equal parts, that would mean that each one is 25 cents. So to graph, I would just put a dot at 4, $4.50, and 5. Okay, so letter C is asking us to write an inequality statement. Again, that just means using less than, greater than, or equal, comparing the possible value of money in our pocket, which we have chosen as $4.50, to the $4. So there's actually 2 statements we can write. 4 is less than $4.50, or $4.50 is greater than 4. 2 different inequality statements with those numbers. Letter D is asking us to do the same thing, write an inequality statement comparing the possible value of money in our pocket, except this time they want us to compare to $5. So $4.50 is less than $5, or $5 is greater than $4.50. Now it's asking us to write one inequality statement that shows the relationship among all 3 numbers. In other words, this is basically asking us to write it least to greatest, but instead of using commas, we're going to use inequality symbols. So the smallest one is 4. 4 is less than $4.50, which is less than $5. Notice this is just least to greatest, but with inequality symbols showing us instead of commas. We can also do greatest to least. 5 is greater than $4.50, which is greater than 4. The last example wants us to do the same thing. Least to greatest, greatest to least with those inequality symbols, except this time we're looking at negatives, and they're all decimals. So what I do is I always switch them all to positives. I use the opposites. So if they were positive, my numbers would be 3.8, 3.75, and 3.89. I want my three numbers to go least to greatest. When comparing decimals, the first thing you should look at is the whole number. Since they're all the same whole number, I'm going to look at what comes after the decimal. If what comes after the decimal is different lengths, I should attach zeros until they're all the same length. Now that they're all the same length, I can just compare based on the number after the decimal. So this would be 80, 75, and 89. If I were going least to greatest, and if these are all positive numbers, it would be 3.75, 3.80, 3.89. However, since these are all negative numbers, it's going to be the opposite. So my greatest will actually be my least as a negative. The middle number is just going to stay the same. And then the least will now actually be the greatest. So I'm just going to rewrite that over here. And I can put 3.80 or 3.8, which it was originally. So this is least to greatest. Greatest to least, we're just going to reverse the same order we had up here. So negative 3.75 is that greatest. Negative 3.8 is that center number, and then our least is our negative 3.89. So again, if you find it helpful to have them all be positive first, like I do, and then do the opposite, that is a good recommendation for you to do.